Imagine unlocking 100% of your brain's capacity. Suddenly you have perfect photographic memory. You can learn any language in hours. You solve complex mathematical equations instantly. You paint masterpieces, compose symphonies, and build billion-dollar companies overnight. You become superhuman. But here's the thing. You've probably heard we only use 10% of our brains. Is that actually true? And if you could access the other 90%, would you really become limitless? The answer might surprise you. The myth, 10% of your brain. The idea that humans only use 10% of their brains is one of the most persistent myths in popular culture. You've probably heard it countless times. It's been featured in movies like Lucy and Limitless, where characters unlock their full brain potential and gain superhuman abilities. According to this myth, if you could somehow access the dormant 90% of your brain, you could do anything. Paint a masterpiece in a minute, learn every language in an hour, build a multi-billion-dollar company overnight, rule the world by tomorrow. The implication is clear. You're not reaching your full potential because you're only using a tiny fraction of your brain's capability. If you could just unlock the rest, you'd be limitless. This idea is incredibly appealing. It suggests that inside each of us is a hidden genius just waiting to be unleashed. We're all capable of extraordinary things. We just need to figure out how to access our brain's full power. But there's a problem with this myth. Actually, there are several problems, and the biggest one is this. It's completely false. Before we debunk the myth completely, let's appreciate just how amazing the human brain actually is. The brain, to say the least, is very complex, unimaginably complex. It contains approximately 86 billion neurons, nerve cells that process and transmit information. Each neuron can form thousands of connections with other neurons, creating a network of trillions of neural pathways. We've studied the brain for centuries, and we're still learning more of its secrets today. Every year, neuroscientists make new discoveries about how memory works, how consciousness emerges, how we make decisions, how we experience emotions, and how all the different parts of the brain coordinate to create the experience of being you. Despite all this research, there's still so much we don't understand. The brain remains one of science's greatest mysteries. But be careful when searching for facts about the brain. The search for knowledge can sometimes lead to fiction. Myths and misconceptions about the brain are widespread, even among educated people. And the 10% myth is perhaps the most famous example. Another common misconception is that brain size directly correlates with intelligence. But that's not quite how it works. Brain size relates more to body proportion than it does to intelligence. For example, compare your brain to a whale's brain. A whale's brain can weigh up to 9 kilograms, while the average human brain weighs about 1.4 kilograms. Your brain is much smaller than a whale's brain. But does that mean whales are smarter than humans? Obviously not. Your brain is smaller than a whale's because your body is much smaller than a whale's body. The whale needs a larger brain to control its massive body. What matters more than absolute brain size is the brain-to-body ratio and, more importantly, how the brain is structured. Your brain is organized in a way that enables you to think abstractly, use language, plan for the future, create art and technology, and build complex societies. You can survive and succeed in ways that whales cannot, despite their larger brains. Even among humans, brain size doesn't determine intelligence. Albert Einstein's brain was actually slightly smaller than average, yet he was one of the most brilliant scientists who ever lived. What mattered was how his brain was organized and connected, not its size. We've all seen examples of what exceptionally intelligent and talented people can accomplish. These people inspire us and show us what human potential looks like. They inspire us through art, creating paintings, sculptures, and photographs that move us emotionally and help us see the world differently. They compose music that can make us cry, make us dance, or make us feel connected to something larger than ourselves. They write literature that explores the depths of human experience and imagination. They change the odds in sports through incredible dedication, training, strategy, and physical coordination. Athletes push the boundaries of what the human body can do, breaking records and achieving feats that seem impossible. They come up with tools and technologies to make our lives easier. From the wheel to the smartphone, from antibiotics to artificial intelligence, human innovation has transformed how we live. and they help organize society as a whole to make us all more powerful, for better or for worse. They create governments, legal systems, economic structures, and social institutions that coordinate the efforts of billions of people. All of this is accomplished with the brains we already have, which brings us to an important point. If we're only using 10% of our brains, how are people achieving all these incredible things? Here's the truth that neuroscientists want you to know. You already use 100% of your brain. Not 10%, 100%. Modern brain imaging technology, PET scans, fMRI scans, and other techniques allows scientists to see which parts of the brain are active at any given moment. And these scans consistently show that we use all parts of our brain throughout the day. Different areas of the brain handle different functions. Some areas process visual information, others process sound. Some control movement, others handle language, emotions, memory, planning, and countless other functions. At any given moment, you're not using all areas of your brain simultaneously at maximum capacity. That wouldn't make sense. You don't need your visual processing centers working at full power when your eyes are closed. You don't need your motor control areas firing when you're sitting still. But over the course of a day, even over the course of a few hours, you use essentially all of your brain. Brain scans show activity throughout the entire brain, not just in 10% of it. There are no dormant areas sitting unused, waiting to be unlocked. In fact, even during sleep, your entire brain remains active. Different regions activate during different sleep stages to consolidate memories, process emotions, and maintain your body's functions. If 90% of your brain were truly unused, evolution would have gotten rid of it. The brain uses about 20% of your body's energy despite being only 2% of your body weight. Evolution doesn't maintain expensive, energy-hungry tissue that serves no purpose. So where did the 10% myth come from in the first place? There are several possible origins, but one likely source is a simple confusion about brain composition. Your brain is approximately 10% neurons and 90% glial cells. This might sound like you're only using 10%, but that's a misunderstanding of what these cells do. Neurons are the cells that process and transmit information through electrical and chemical signals. When people think of brain activity, they're usually thinking of neurons firing. There are many different types of neurons that handle different functions, but in general, your neurons enable you to think, feel, remember, and control your body. But neurons can't function alone. They need support. That's where glial cells come in. Glial cells surround your neurons, providing them with structural support, insulation, nutrients, and protection. They help maintain the right chemical environment for neurons to function properly. They clean up debris and fight infections. They regulate blood flow to active brain regions. They even play roles in learning and memory formation. In other words, both neurons and glial cells are essential. You're not using 10% and wasting 90%. You're using 100% of your brain, with different types of cells performing different but equally important functions. Another possible source of the myth comes from studies showing that damage to certain brain areas doesn't always cause obvious impairments. But this doesn't mean those areas aren't being used. It often means the brain has remarkable plasticity and can sometimes compensate for damage by reorganizing itself. But let's imagine for a moment that the myth were true. If you could somehow unlock the mysterious 90% of your brain that's supposedly dormant, what would happen? First things first, you'd finally get to solve that Rubik's Cube that's been collecting dust on your shelf for years. You pick it up, and the solution would just come to you instantly. Every move mapped out perfectly in your mind, solved in seconds. You could call up your smartest friend and challenge them to a game of chess. Checkmate in 2 moves. You'd see every possible move and counter-move simultaneously, making you unbeatable. When you're done being a smarty pants, you'd be looking for real challenges. Because here's the thing about being exceptionally intelligent. You won't be as stimulated by the things that keep us ordinary folks happy. Simple pleasures might bore you. You'd need constant intellectual stimulation. But when you're limitless, you don't have to choose between pursuits. You could do everything at once. Picasso was overrated. I could do better. And you'd paint a masterpiece that puts his work to shame. Sorry I'm late to the meeting. I was up all night curing cancer. and you'd have the research to prove it. I had this crazy idea for a time-traveling toilet, so I just built one. And there it is, sitting in your bathroom, ready to transport you to any bathroom in history. Sounds amazing, right? Unlimited potential, boundless capability, the ability to accomplish anything you set your mind to. But there's a catch. Actually, several catches. Body limitations. You can't dedicate it all. Okay, let's back up a moment. What actually happens to your body when you're dedicating all of your brain's energy and processing power to creating art, curing diseases, or inventing impossible technologies? Here's the problem. Your brain is already working full-time, just keeping you alive. Your lungs breathing, that's your brain. Specifically, your brainstem automatically controls your respiratory rate based on carbon dioxide levels in your blood. You don't have to think about breathing, your brain handles it for you. Your heart beating, that's your brain too. Your brainstem regulates heart rate and blood pressure constantly, adjusting based on your activity level and other factors. Your food digesting, your brain again. The enteric nervous system in your gut works with your brain to control digestion, moving food through your system and extracting nutrients. Your blood circulating, your temperature regulating, your hormones balancing, your immune system fighting infections. All of this is managed by your brain, mostly automatically through your brainstem and autonomic nervous system. Even if you could somehow access 100% of your brain's capacity simultaneously, you couldn't actually use it all for conscious thinking and problem solving. You would be fundamentally limited by your body's survival needs. If you tried to dedicate all your brain's processing power to solving complex problems, your automatic functions would shut down. You'd stop breathing, your heart would stop beating, you'd die. Your brain has to multitask. It has to keep you alive while also allowing you to think, feel, and interact with the world. You can't just reassign all those survival functions to work on curing cancer instead. There's another major limitation: energy. Your brain is already an incredibly energy-hungry organ. Despite making up only about 2% of your body weight, your brain uses approximately 20% of your body's total energy expenditure. That's enormous. Your brain burns through roughly 300 to 400 calories per day just performing its normal functions. Why does it use so much energy? Because thinking is expensive. Every time a neuron fires, it uses energy. Maintaining all those neural connections requires constant energy. Processing information, forming memories, regulating your body, all of this requires fuel in the form of glucose and oxygen delivered by your blood. Now imagine if you could somehow increase your brain's processing power and use even more of its capacity simultaneously. The energy requirements would skyrocket. You'd need to consume massive amounts of calories just to fuel your thinking. You might need to eat constantly throughout the day to keep your brain supplied with enough glucose. And all that energy usage creates heat. Your brain already generates significant heat, which is why your head has a sophisticated cooling system involving blood flow. If your brain worked even harder, you'd need to deal with potentially dangerous overheating. Evolution has optimized your brain for a balance between capability and efficiency. Making it work harder comes with serious trade-offs. This raises an interesting question. If having a more powerful brain would be so beneficial, why didn't evolution make our brains bigger, faster, and more efficient? The answer is that evolution has already optimized our brains for our specific ecological niche. Further improvements would come with costs that outweigh the benefits. A bigger brain requires more energy, which means we'd need to eat even more food. In ancestral environments where food was often scarce, having a brain that required constant feeding would be a disadvantage, not an advantage. A larger brain also makes childbirth more difficult and dangerous. Human childbirth is already one of the most difficult and risky among mammals because of our large brains. Making brains even larger would increase infant and maternal mortality. Faster neural processing might seem like an obvious improvement, but it would require neurons with different properties, which might make them more fragile or energy intensive. The current speed of human thought represents a balance between speed and reliability. Our brains are already remarkably capable. We can do things no other animal can do. We've built civilizations, developed technology, explored the universe, and created art. We accomplished all of this with the brains evolution gave us. If there were easy ways to make human brains dramatically better without serious costs, evolution would have found them over millions of years of natural selection. The fact that it hasn't suggests we're already operating near optimal for our situation. Here's something that might surprise you. Your brain has just as many neurons as Albert Einstein's brain did. You have the same biological hardware that produced the theory of relativity. Einstein wasn't smarter because he had more neurons or used a higher percentage of his brain. He used the same 100% of his brain that you do. What made him exceptional was likely a combination of factors. How his particular brain was organized and connected, his education and training, his curiosity and creativity, his persistence in thinking about difficult problems, and yes, some element of luck in being in the right place at the right time, with the right problems to solve. The point is that you already have an incredible brain. You don't need to unlock some hidden 90%. You need to take care of the 100% you're already using. Maintain healthy habits. That's the smart thing to do. Get enough sleep, because sleep is when your brain consolidates memories and clears out waste products. Exercise regularly, because physical activity increases blood flow to your brain and promotes the growth of new neural connections. Eat a nutritious diet with plenty of fruits, vegetables, and omega-3 fatty acids that support brain health. Challenge your mind with new learning and experiences to build cognitive reserve. Manage stress, because chronic stress can damage brain structures. And of course, protect your brain from injury. Wear helmets during risky activities. Avoid excessive alcohol and drugs that can damage brain tissue. It's a no-brainer. Your brain is already amazing. The 10% myth suggests you're not living up to your potential, but the truth is you're already using your full brain. What you do with that amazing organ is up to you. Conclusion: you're already limitless. So what would happen if we use the full capacity of our brains? The answer is we already do. The 10% myth is just that. A myth, a persistent, appealing but completely false idea about how the brain works. You use 100% of your brain, just not all at once or in the same way. Different parts activate for different tasks throughout the day. Your entire brain contributes to making you who you are. There's no hidden reservoir of untapped potential locked away in your skull. But that doesn't mean you can't improve your cognitive abilities through learning, practice, and healthy habits. You can always get better at specific skills, learn new information, and think more effectively. The real limitation isn't that you're only using 10% of your brain. It's that your brain, like any organ, has physical and energetic constraints. It's already optimized by millions of years of evolution to be as good as it can be given the trade-offs involved. So the next time someone tells you we only use 10% of our brains, you can confidently correct them. And maybe, just maybe, you'll inspire them to appreciate the incredible 100% of the brain they're already using. If you enjoyed learning the truth behind this famous myth, subscribe for more explorations of how your body and mind really work. Stay curious and make the most of that amazing brain you have.